also call them complex numbers as well. And a complex number is just an imaginary part and a real part put together, like 3 plus 2i. That's a complex number. Okay? So with this being said, you guys know the graphs when we had the parabola that looked like this or looked like that? How many x-intercepts do those graphs have? None. They don't cross the x-axis whatsoever, do they? So therefore, there's still values of x's that make those graphs, but we have no x-intercepts. So how could we solve this? Well, not everything's always graphed in the Cartesian plane, which is the xy plane. Sometimes things are graphed in the imaginary plane, which is we have a real part and an imaginary part. It's very simple. Like, how would I graph this guy right here? 3 plus 2i. This is called your real. This is your imaginary. With I. I'd go 3 over, up 2. Oh my goodness, that's so hard. That's the imaginary plane. Now, I'm not going to ask you guys to do this stuff. It's not part of our course, nor did I ever do it really ever anyway. But it is possible, and then we could graph using those imaginary numbers to actually find where it crosses this axis in the imaginary plane. Okay? Remember how I talked to you guys about values? What was an x-intercept? Where we cross the x-axis, right? Remember what other words did I ask you to find? Zeros. Technically what we did yesterday was finding the zeros of those equations, correct? Okay, those are the values that make it 0. Well, there are numbers that make it 0. Okay? Let me guys ask you this question. What's the square root of negative 4? Why, Rich? You said nothing. Why? Exactly, okay? So, this is what he said. He said, nothing times itself is ever negative. Correct? Because isn't a square root looking for groups of 2? Right? 2 times 2, that's a group of 2. 3s, 3 times 3 is 9. Those are perfect square roots, right? What times itself is negative 4? It didn't come up. Okay? But then they kept doing some math, and they kept seeing these numbers pop up. So they're like, it has to do something with math. Because you've got to think about how was this stuff discovered, right? As they started going through it, they had some rules that made sense, right? And then they see this stuff that keeps coming up. Like, why is pi a cool number? Radius. It helps in circumference of a circle. And that number kept coming up. Okay? And so they saw it, and that was a special number, so they gave it a thing. Pi. Right? Does that make sense? Okay? Same with I. These negative square roots kept coming up. So they're like, something has to happen with this. So, this is equivalent to 2i. I is the imaginary number square root of negative 1. Okay? I is the same thing as the square root of negative 1. So how do I make this 2i? Well, what's square root of 4? Isn't that square root of 1? Square root of 4? Negative 1 and square root of 4? So it's the same thing, right? What's the square root of 4? 2. What's the square root of negative 1? That's an imaginary number. This is as hard, well, not hard, but this is what an imaginary number is. Yes. Yes. That's why you hardly ever see variables as I, because you have something for I. Does that make sense? Okay. So, curiosity, what would I squared be? Anybody have an idea? What do you guys think? Yes, sir. It would not be 1. Negative 1. Because doesn't it squared? Because isn't that then this? I squared. And what does a square root and square do to each other? They're opposites, right? So that comes negative 1. That is important that you know that I squared is negative 1. Now, not in this class, but in future math classes, it's important to also know that we continue a pattern. Okay, what do you guys think I to the third is? Wasn't that I squared times I? Isn't I cubed I squared times I?
Yes.
What's I squared again? What did we just call that? Negative 1 times just I. We're just going to leave it with I, though, which is the square root of negative 1. So I cubed is the same thing as negative I. Okay, we're almost done with my pattern here. And this is kind of nifty to see. Hopefully, if you think about it. I to the 4th. We'll go to I to the 7th and we'll be done. Okay? Now you might be like, why am I doing this? Well, it's kind of cool. What's I to the 4th? Well, isn't I to the 4th I squared times I squared? What do you think it is? Because that's negative 1 times negative 1, isn't it? So that's the same thing as 1. I to the 4th is the same thing as 1. Okay? So what do you guys think I to the 5th is? Now you might be saying, why do we keep doing this? I'm just trying to show you a pattern. It's the same thing as I, because I got I to the 4th times I. Well, what is I to the 4th? 1 and 1 times I is I. What do you guys think I to the 6th is going to be? I to the 4th times what? Okay. So therefore, what's I to the 4th? What's I squared? Not 1. Negative 1. I to the 6th is negative 1. Okay, what do you guys think I to the 7th is going to be following our pattern? It is going to be negative I because I have I to the 4th times I cubed. I to the 4th is 1, and what was I cubed? It will only be anything raised to I raised to any power will only be 1, negative 1, I, or negative I. You should never have I be raised more than to the first power. That's the highest it ever is as a reduced number. So, in past, I've asked kids this question. What is I to the 89th? Now you're like, holy crap, Mr. Roberts, you want me to go all the way down to 89? No, I don't. Let's come back up here a little bit. Notice how many times can 4 go into 6? Once, right? With 2 remaining. How many times can 4 go into 7? Once with 3 remaining. So then I ask myself, same thing here. I say, okay, how many times can 4 go into 88? 22, so I can go I to the 4th to the 22, because what is a power to a power? Don't we multiply? So that's I to the 88th, isn't it? How many's left over? 1. What is I to the 4th? Get your notes if you need to. 1, and 1 raised to any power is 1. And what's 1 times I? No matter what the power is here, when I simplify it, it either can be I, negative 1, negative I, or 1. That's it. Sir. Exactly. And think about I to the 9th again. Isn't that I to the 4th squared times I? Because what's 4 times 2? 8, and there's 1 left over, right? So all you really have to do is say, how many times can 4 go into this number? So if I even had I raised to the 10,352. That's a big number. I don't really care. Okay? How many times can 4 go into that? Well, let's do some long division. 4, that's a 2, that's an 8, 20 by 2, that's a 3, that's a 5, that's 20, that's a 3, 5, 8, 32, 3 bring it down, 2 goes in evenly, huh? Because it goes in evenly, do I have any remainder? So guess what this is equivalent to? 1. If it had remainder 1, what do you guys think it's equivalent to? I. If it had remainder 2, what do you guys think it's equivalent to? Negative 1, because it's equivalent to I squared. If it had remainder 3, what do you guys think it's going to be? Negative I. It has that pattern. If you have remainder 0, it's exactly 1. If there's remainder 1, it will be I. If there's a 2, it becomes I squared. If it is remainder 3, it becomes negative I. Yes, sir? Sure. All right. It went in evenly. That's the key part. Right? Yes. Good. Thank you. Okay. That used to be on our core, but it's not now. But it is something useful when we get to higher numbers. When you get into higher math, this stuff is going to be used. Okay? But right now, they're not asking us to go that high. So, only thing you need to know, though, is what is I? It's equivalent to square root of negative 1, right? What is I squared? Negative 1. Those are the things that you do need to know. Okay? Alright, so somebody tell me, what is the square root of negative 49 plus the square root of negative 25? Okay, so what is the square root of 49? 7, and because it's negative, it's going to be 7i. Does everybody understand that? Anytime you see a negative underneath the square root now, you're going to think of an imaginary number I. Okay? Square root of 25. So this would be 5i. So what does that come out to be? Because then you treat it like a variable. Do they like bases? Like terms? They are, so I can combine them. Okay? Does that make sense to everyone? Yeah. Yes, ma'am.
Is it always going to be positive if there's negative turned out?
Not unless it looks like this. Not always. This could be negative square root of negative 49. What does that come to be? Negative. This comes to be 7. Does that answer your question? Okay, too? Odin, you alright? Anybody have a question? You could still, remember how we rationalized, let's say, 108. Let's do negative 108, okay? So 108 is not a perfect square root, is it? But we can still break it down. Remember breaking down square roots in our first unit? Where we got to look for, because this is a 2, we're looking for groups of 2, correct? Where this is 9 and 12, which is 4 and 3. 2, 2, 3, 3. So there's a group of 2, there's a group of 2, right? So this becomes 6i root 3. Where does that live? Just because it looks weird doesn't mean it's bad, right? Just got to find out the groups, times them together. The I came from the negative, right? And there's just a 3 left over, so he has to stay in shell. Just a stretch. It's actually a fairly simple, is it a tedious concept? Sure. It's fairly simple. Yes, sir. Well, where's 9? 3 times 3, but remember, what is the square root of 9? 3, so he gets to come out with the square root of 4. So 3 times 2 gave me my 6. Yes, no? Are we okay? Sure. I could. It doesn't matter, right? So what you just said is 9 and 12, 6 and 2, 3 and 2, there's a group of 2 again. Either way, so. Okay. You guys ready for the hard stuff? Here Here we go. 4 plus 2i, which this is called a complex number. It has a real part and an imaginary part added together. Plus 5 minus 3i. You guys ready for this? This is so hard. Anybody give a guess on what the answer is? What do you think, Hunter? Wow. Yes. That's it. Adding complex numbers together is really simple. It's very elementary, isn't it? Treat it like a variable and you'll be fine. Right? Does that make sense to everyone? Sir? No problem? 4 plus 5? 2i minus 3i? So now, let's go on to the next one. 4 plus 2i minus negative 7 plus 3i. Do I really have to have parentheses around the front, guys? I don't, do I? So this would be 4 plus 2i. Give me 1 second. And then what do we do with this negative? We distribute it to both terms. How many of you guys forget to do it to both terms? There's a bajillion that forget. Make sure you do it to both, so that becomes plus 7 minus 3i. Does that make sense? Because we got to distribute the negative through. Then, as we combine it now, Alex, what do you get? And people ask me, does it matter, Mr. Roberts, if I go negative I plus 11? Yes and no. No, because this means the same thing. Yes, because they like to write complex numbers in the real plus the imaginary. Does that make sense? Maggie? Yes. These are the same thing, which they are, but the only reason why we would not write it that way is because that's not how we write a complex number. A complex number is the real part plus the imaginary part. Okay? Am I killing anybody so far? Pretty simple, correct? Okay. So now we've done adding, we've done subtracting. What do you think we're going to do now? Woohoo! Some people still struggle on what to do here. What do you do at this stage? Do I say that's 10 plus I? I gotta FOIL that sucker, don't I? Distribute, if that's a better word for you. So I go 4 times the 24. 4 times the 6. 24. Penny. I have that penny back. Every penny adds up. So you want it? Don't throw it. 4 times negative 2i. Pretty simple, isn't it, so far? 3i times 6. 3i times negative 2i. Negative 6i squared. Is it crossed? Answered your own question, didn't it? So, ladies and gentlemen, boys and girls, I'm at 24 plus 10i minus 6i squared. Am I completely done? There's no more terms. I can't add any more terms together, can I? So is this done? Why? Timmy? You can. Sure. or that's called standard form. Shaded. Would be negative 6i squared. Michael. Remember, can you have anything higher than the power of I to the first? It is not simplified if you have anything raised higher than I to the first. So therefore, what is I squared, as Michael said? That's the same thing, Jackson, as negative 1, isn't it? So therefore, I'm at 24 plus 10i plus 6. Say again, sir. Negative 6 with a, you could say negative 6, right? Which changes me into 30 plus 10i. Any questions on that? What's 24 plus 6? You're good. You just didn't see it. Was that hard even? Really not a hard day today, guys. Really it isn't, I promise. Okay? So, do I need it? Yes, I'm going to do it. As you guys split the puzzle. Go. Try it by yourself. 13. Okay, I got a 13. That's an answer. What did you get, Mike? 13 minus 12i. Ridge. 9 minus 4i squared. Awesome. Bryson. 5 minus 2i. Great. 5 minus 12i. Awesome. I don't know if any of these are right. I'm just writing it down. What'd you get? Ooh. Okay, we're getting on this thing. What'd you get?
5 minus 12i.
5 minus 12i? Does everybody have an answer up there? What'd you get? 11. Awesome. Let me hear and see what this is going to be. The answer is not up there yet.
Yes, it is.
Oh, what did you say? Oh, the answer's up there now. Megan. Huh? 5 plus I? Alright. Last, here we go. What'd you do? 13 plus 12i. Okay, I can see that one as well. That was close. You said minus? Okay, it's up there. Alright, sweet. How many guys just went like this and brought him in again? You cannot do that! It is not legal. You should get arrested if you do that every freaking time. Once again, I ask you this question. What does 3 squared mean? And don't tell me 9. 3 times 3, doesn't it? So what does 3 minus 2i squared mean? You cannot bring him in. Okay? Which is where the 13 came from. Which is where the 5 came from. You cannot bring in a squared. Okay, so then we go ahead and distribute through. 3 times 3. 9. Minus 4i. Thank you for those that at least gave their a try. At least you tried something. I appreciate that. 6i. I am sucky adding today. Negative 6i again. Plus 4i squared. Ooh. The answer is up there, and that was wrong. Hi.
It's 5 minus 12.
In this class, I do not. Next class, yes. I messed up. It's 5 minus 12i. Because, sorry about that, ladies and gentlemen, because this becomes what? Negative 4. So that is 9 minus 4, which is 5, minus 12i. I apologize to those people that got it right, and I did not associate it with you. style I grew up in. Not this bullshit. Hey guys, I put a sticker on my hat too. No offense to that sticker on your hat, but I think it's leave a sticker on it.
And the sticker probably goes off and looks like the one spot that they put.
Because what is I squared? Nothing wrong. Negative 1 times 4. Are you okay with that now? Is everybody good with that?
Yeah.
I guarantee people struggle with this still. Can I ask how many people distributed through a squared? You cannot do that. Let me ask you this question. When in doubt, if you guys are not sure, when in doubt, try this. What's 3 plus 2 squared? What should it be? 3 plus 2, which is 5, and 5 squared is, because order of operations says to do inside the parentheses first, right? When you don't do that, what are you doing? You're doing order of operations out of order, right? Because you're doing the exponents and then inside the parentheses, aren't you? Okay, you're saying, oh, that's 9 plus 4, which is 13. It doesn't equal each other, do they? If it doesn't work with numbers, it doesn't work with the variables. Okay? It's a very simple way to check. All right. Last one, I think we're getting there. I think that's the last thing to do, is dividing. So if I had 4 divided by 3i, what's that simplified down to be? It simplifies down to 4 divided by 3i. That's what it is. But, because I is a square root, correct? I don't know if we've ever talked about rationalizing our denominators. Okay? I cannot have a square root in my denominator. It's not allowed. Okay? Because back in the day, when they didn't have calculators, they couldn't divide by square roots. Think about it. Why can't you divide by a square root? It's because you don't know what that number is. What's the square root of it? It continues on as a decimal, doesn't it? Right? Does that make sense to everybody? So what we have to do is get rid of that square root. And what we do is times by the square root again. So I times by I. Why do I times I to the bottom? Can I just times I to the bottom? Is that possible and legal? What I do to the bottom, I got to do to the top, right? Is everybody there with me? To the bottom? It is. To the top, it's okay. Because what? Say if I have square root of 6 divided by 2, I know square root of 6 is going to be in between 2 and 3, don't I? How do I know that? Give me a second. So I know it's in between 2 and 6, probably closer over here. Or actually, closer to the 2, so maybe 2.4-ish. You can get a rougher estimate. Does that make sense what I'm saying? And then divide that by 2. You have it that way. Does that make sense why it's okay to have it on top? Really, this is an outdated thing, I'll be honest with you, but in mathematical, what it is, like on your end of the year tests, on your ACT, they still rationalize their denominator. So it's something that we still need to know. Okay, and so just like you said, Ethan, this becomes 4i on top, doesn't it? But what's I times I squared, which is negative 1. Huh? So therefore it becomes negative 3. And we really like to end our problems with negatives in our denominator. No, so just write it negative 4i over. Okay. Everybody okay with that? Got you all right? Notice there's no I in my denominator, is there? But they're not always this easy. Maybe I'll have one that looks like this. 6 over 3 plus 2i. You see how we have that in our denominator, that I? So can I just times by 2i, or I top and bottom? Why can't I do that? Because of the 3. Because if I times the I, yeah, it gets rid of him, but then he has an I, doesn't he? Does that make sense? So, how many guys remember, what did this guy on number 2 factor to be? Yeah, there's no middle term. Didn't he factor down to be x minus 3, x plus 3? And I think we talked about these last time. Does anybody remember the word I used for this? These are called conjugate pairs. Conjugate pairs. This is important, you might want to write these down. Conjugate pairs. Notice they still have the same coefficients, don't they? X and 3, x and 3. What's the difference? The signs are different in the middle. So can somebody tell me what is the conjugate pair of 4 minus 2i? The conjugate pair would be 4 plus 2i. Okay? And why would I want to know this? Well, when I go ahead and multiply, I'm going to scroll down for a little bit. What I'm going to do is I'm going to multiply my bottom by its conjugate. What I do to the bottom, I got to do to the top, don't I? Now, why am I doing this? Watch what happens when I go ahead and distribute the top. Does everybody see how that 6 times 3 is 18? 6 times that is negative 12i. Is everybody okay at least with that? Now when I go ahead and start working the bottom, I have to do some distributive property there as well, don't I? So I have 3 times 3, which is 9. 3 times negative 2i is negative 6i. Plus 6i, what cancels there? Our i's are going to be gone, and that's what conjugates do, is they'll get rid of the I. Well, not really, because this would be negative 4i squared, but what do we know about I squared? Negative 1, so our i's are all going to be gone, aren't they? Because these guys are gone, right? And that's the key thing about conjugate pairs. Your inner and outer terms will always cancel each other. And then notice this is negative 1. So I have 9 plus 4, which is 13. So I'm at 18 minus 12i over. Was that a little hard? How did I do that, Anita? Okay, so do you understand the top? You don't understand how I got 18 minus 12i? I just distributed the 6 to the 3 minus 2i. How did I get the 6? It was already there. I did the conjugate pair. What's the conjugate pair of 3 plus 2i? 3 minus 2i. Does that make sense, Ridge? So what I do to the bottom, I got to do to the top, correct? That's where that came from. Ridge, are you okay there? Then I multiply through. That's where I got the 18 minus 12i. And then I multiplied through the bottom, and that's where I got 9 minus 6i plus 6i minus 4i squared. But what's negative 6i and 6i? Nope, negative 6 plus 6? 0. They cancel each other out, reduce out, don't they? What's I squared again? So negative 4 times negative 1 was the 4. 9 plus 4 is 13. That's what I got. Tim. Really, that wasn't too hard either. It's just a little bit more work, a little bit more tedious, right? Okay, let's try this last one. This is it. Okay, I have an I in my denominator and an I in my numerator. Can I just cancel those i's out? No, which I see all the time. You can't just cancel things out. If they were timesing, sure. But since this is an addition, these two are stuck together. Okay? So what am I going to multiply? Top and bottom. 3 plus 4i. Because that is the bottom's conjugate. Because who doesn't want the I? The denominator. So that's why we times by our denominator's conjugate. So I'm going to FOIL the top. 15 plus 20i plus 6i plus 8i squared. Does everybody see how I did that? And that becomes negative 8. Does that make sense to everyone on there? I'm in a hurry and run through the bottom really quick before I combine my term. 3 times 3. 9 plus 12i minus 12i minus 16i squared. Just FOIL the bottom. Notice once again, what do the middle terms do? They reduce out, and that's why we just did the conjugate. Okay? And this guy becomes plus 16. Everybody see where that 16 comes from? Because it was a negative 16i squared. And what is I squared? Negative 1. Negative 1 times negative 16 is 16. So, here we go. Now we're going to combine like terms. 15 minus 8 is 7. 20 plus 6i, 20i plus 6i is 26i. Over 9 plus 16 is 25. There's our number. You might also see this as this. 7 over 25 plus 26 over 25i. Because when I divide the whole thing by 25, I can just put 25 underneath each factor. Okay? It's a pretty simple day, guys. This is more of an algebra type based question, a very basic thing, than a higher thinking skill. The reason why it's higher thinking skills is because we needed to know what a quadratic looked like to show that it has no x-intercepts, right? And then therefore, because there's no x-intercepts, we can still find values that make this 0, which are the imaginary numbers. Okay? It's really not too bad of a day, though. Okay? All right.